actually theory heavy. What is your guess? If you think about the subjects like biology, it's theory heavy, Puta. There are a lot of theories, explanations that you need to understand and you need to remember, right? Your memory will be measured in the exams, right? There are subjects like combined maths, where you have a lot of calculations, lot of questions to be discussed rather than theories. And there you need more analytical thinking, right? More analytical thinking, and you should be able to like solve questions very fast, right? Speed matters here, right? So combined maths, where you have a lot of calculations. If you think about a subject like chemistry, it's like somewhere here. So physics probably somewhere here. ICT probably somewhere here, right? Now why I'm telling this, Pudha? Because based on the nature of the subject, the approach, the strategies you need to apply and follow to learn the subject would be different, right? You cannot apply the methods used in biology to learn physics. You cannot apply the methods you use in physics to completely understand combined maths. Three different games, Pudha. Three different games. Although there are interconnections between the subject's content, you have to follow different methods. You have to follow different methods to understand the subject and master the subject. So in my program, what I'm doing is I'm going to specialize this area and I'll teach you how to master these subjects step by step, right? With a 4-dimensional framework. I'll explain this one in detail when I am actually teaching the subject, right? How these 4 levels are actually developed. Okay, Buddha. Now you understand how the nature of the subjects, right? Let's dive into the subject, right? Physics. What kind of things we are going to learn there? So physics is all about Buddha, understanding the universe and understanding how it works. Okay. So physics is all about that. So this is the starting point of your probably a very long journey in physics. Some of you here might end up doing PhDs in physics, right? Working in Silicon Valley companies, right? In electronics, right? Probably in the aviation field, right? Probably in NASA, who knows? There are a lot of Sri Lankans who are actually working in US now, right? Doing PhDs there, right? Working on these large companies. Some may end up working on artificial intelligence, right? Still related to physics, right? So what is our starting point here, Buddha? What are we going to learn in our A-level syllabus in next 2 years? We are going to master 11 areas. I cannot say master, but we are getting some introduction to the 11 areas. It's still very complex. The first one is unit and dimensions, or we call the topic is measurement. So it's all about understanding what is a physical quantity, how to measure it, what are the tools we are using to measure them, all those things, the very basic stuff, the entry point. Then we discuss about the mechanics. How car is moving, how plane is moving, right? Why objects we are throwing upward actually coming down. We learn the scientific explanation for all these phenomena, right? To the mechanics. Then we talked about oscillations and waves. Where we'll be learning how sound works, how light works, right? It's all about waves, right? There will get better understanding how human eye works, right? Oscillation and waves. Then we talked about the thermal physics. There we will be learning about the concept like heat, temperature, how the heat is transferred from one place to another. Can it transfer through air? Can it transfer through metal? Can it transfer without any of these materials, right? Radiation, we call it, right? We'll be learning a lot of things, right? Inside that, right? Inside that. The next thing we are going to learn about is fields, Buddha. Fields, we are learning about three different types of fields, right? How the gravity works, why things are falling down. It's because of the gravitational field, right? We talked about gravitational fields, right? Then we talked about electrostatic field, how charges actually attract and repel in each other, right? It's laid the foundation to the concept like electricity, right? Then we talked about magnetic fields. Magnetic fields. So this is where we learned how magnets are attracting each other. What is the south pole of the magnet? What is the north pole of the subject magnet? How we define it, right? What is the relationship between electrostatic fields and magnetic fields, right? Can we produce current using all these two fields, right? With different methods. We are going to discuss about those things. Then we'll be talking about the current electricity. I don't need to explain this one, right? You already know what is current and all right, but we are going to learn about electricity in detail, right? Using the concepts in physics. Then we will be learning about electronics. I also did my degree in engineering, first degree in this domain, right? Electronics and telecommunication. This is probably one of the largest industry in the world right now, right? Semiconductor industry. So we'll be having some introduction to this area during our A-level syllabus, right? Then we'll be talking about mechanical properties of matters. What if we apply a force on a string? What if it is stretched? What will happen to it, right? What are the features? What are the qualities of those kind of materials, right? We talk here mechanical properties of matters. Then the final lesson is the matter and radiation. There we'll learn how energy can be transferred from one place to another through radiation, right? Through radiation. So this will be our syllabus, Buddha. 11 topic. We'll be getting an introduction to different domains in physics. That's probably the starting point to learn about many different engineering fields and science streams in future. Okay, Buddha. So this is our syllabus. So we have to complete all these 11 units within 2 years. 2 years. Okay, Buddha. Right. Now let's come back to one more thing. So what will be our exam structure then? Okay, so said like, okay, we have 11 units to cover. So what will be my exam structure now? So we have a 5-hour exam, right? That means in 2028, you are going to sit for an exam and it will be a 5-hour paper, which is divided to two parts, the first paper and the second paper, right? This is 50 MCQ questions. The important thing here, Itupta, this will give you 100 out of 50 of the final mark. So that means this is a very important piece. Then the second paper again divided into two parts here. The structured paper and the essay paper. Okay. So structure, it is all about checking our knowledge about the practicals, right? So we have uh, around 40 practicals to do, right, related to different domains. So there will be 4 questions checking your knowledge on those practicals, right? Then there will be 5, 6, 7, 8, 9, 10. Out of these questions, Pita, you have to write 4 questions. Some questions as part A and B also. We can learn these things later, right? But at the end of the day, you have to write 4 questions. So another 50 will be allocated to this paper. This is how your final mark is calculated, right? So if you are learning physics and other A-level subjects, this is the first thing you need to understand. What is the exam I am going to face? How complex it is? What should be my game plan here? Right? 50 MCQs, 50 marks, right? Very important part. So I should master my MCQs, right? How I can strategize my essay questions? Do I want to master all these every area? No, you only have to select 4 questions. That means at least 5, 6 questions you can get ready, right? There are different ways, right? But the end goal should be getting an A, right? Getting an A. Okay, Buddha. So this is the exam structure. Is it over? No. There are more important things to be discussed. Now we understand why we started learning science streams, what are the opportunities we have, the nature of the subjects, how subjects are interconnected with each other, right? What is our syllabus? What are the areas we have to learn? And what will be my exam, right? And how should I strategize it to find and come up with a better result? Haribula. Now, to do all these things, you have 2 years, right? You have 2 years. So how you should spend it? Right. For that one also I'll give an explanation. Now this is where you are right now, Buddha. Just after all levels, right? This is probably your last 11 years from starting from grade 1. Now you are here. Okay, now you are here. Think about uh, after let's say 6 years or 8 years, your age will be probably around 24, 25, right? Imagine you are going for a job interview, right? You are going for a job interview. Probably the head of the department or head of the company is going to interview you. Is he going to ask you about your O-level results? What is your mark at grade 5? I don't think so. No one is going to ask. The qualifications they are most probably checking is the A-levels and the degree you have. What is the meaning of that, Buddha? These 2 years are probably the most important years of your life. No matter how well you have reached up to this point, if you can't handle the pressure, if you can't handle the workload here, you will end up in a very bad situation, right? So make sure, Buddha, these 2 years are the most important 2 years of your life. Hurry. So then you have 2 years. You have 2 years. How you are going to spend it? 2028 here. It's a long journey, right? It's not a easy one. You have to climb a steeper mountain, right? How you are going to spend your next 2 years? Some people can do this way. Okay, I have 9 years for the A levels. All was only 3 subjects. We did 9 subjects and got 9 years. 3 years, 3 subjects is nothing. Okay, I'll probably spend more leisurely my first 6 months, right? Then I'll start working on this, climbing the ladder. This is some person thinks about. Some might even smarter than that, right? Those people, he thinks, okay, all of us, I think I got 9 years within 1 month. By studying only 1 month, why I can't apply the same theory here? I'll spend probably 1.5 years. I don't want to focus too much. Probably last 3 months, last 4 months, I'll start working. I'll climb this mountain. None of them going to succeed today, right? None of them going to succeed. That's the other side of the story. Some people think, okay, if I work really, really hard in the first 3 months, I can spend rest of the month leisurely. What do you think? Is it going to work? Is this method going to work? So this is part 1. This is part 2. This is part 3. Do you think part 3 is going to work? That is also not going to work, Buddha. That is also not going to work. The reason why I told you we have 11 units. So you put your entire energy, I mean all energy here, probably in 2 units, and you try to spend leisurely on these 9 units. What will happen to that? Probably these 2 units will cover, let's say, probably 15% of the total mark. Rest 85 is actually connected with these 9 units. You cannot take rest, even working harder in the early months. That's not possible. So what is the right way? The right way is, Buddha, you should start from day 1, make consistent progress. That's the only way. No other formula. Okay, Buddha? There can be night seminars, right? Working for 16 hours continuously without sleeping. Don't believe on magic, Buddha. Start working continuously from day 1. This is the only mantra for success, right? Don't overwork. Don't be too lazy. Find the right balance, right? Find the right balance. It can be different from person to person as well, right? That's the next thing I am going to explain, right? I hope you understand what kind of journey we have, right? Start from day one to the put the right effort, you will be succeed here. Okay. As I said, the amount of work you are going to do can be different from person to person, right? So how to manage that? This is a common question. I mean, common things I have observed when working with students like you. Like sometimes they think, okay, my friend is actually, I mean, doing homework only for 2 hours, only 2 hours per week, 2 hours per day. I'm probably spending 5, 6 hours per day. Still, my marks is not good. So can't I enter into a university? I'll explain this scenario using an example, right? I hope many of you have heard or have actually climbed the Adams Peak or Sripada, right? How many paths we have there? There are different lengths, different difficulties. There are four paths actually, right? Some of them are very long and very difficult. Some are easy and probably shorter paths. So all of you here will have to go through one of these paths. It's based on your capacity, right? So there can be people who understand things from the when they hear it for the first time, right? There can be people who want to listen into multiple times, right? Probably do more homework, right? But after doing that, they are also good in that area, like this, right? Here the person understanding first time, but these people do it for 2, 3 times, but skill level is now same. Skill level now same means Puta, your final results will be same. Huh? Your final results will be same. The first thing I want to tell you, Puta, don't compare you with anyone, right? When you start A levels, don't compare you with anyone, right? You have your own version, right? Don't worry. If you follow the right path, you will definitely end up here. It can be longer, it can be difficult than the others, but still you will reach here, right? Still you will reach here. What is the second thing? If you have climbed the Adams Peak or Sripada, what you have seen is like people are enjoying this journey, right? They are singing, right? They collaborate with each other, right? They share food with each other, right? They help each other. Do that for in your level journey as well, right? No matter how difficult it is, always enjoy the journey, right? And you have seen there are several points to rest, right? You can say like Sita Gangula, right? Katupana, what else, right? There are many places where you can take a rest, then start climbing, right? Your level journey also like that, Buddha. Take rest whenever you want, right? Don't exhaust, right? Don't take stress too much. Take the rest at the right moment, right? Accumulate more energy again. Go to the next step. I'm pretty sure if you have the right teachers, right guidance, and if you follow this path, you will definitely end up getting an A and entering into a university. right, Buddha? So this is what I wanted to tell. I think I took probably around half an hour, right? But before starting a lesson, Buddha, I want to tell these things because that will help you to shape your next 2 years, even with me or without me. But make sure that you follow these things, right? You will be succeeded in your A-levels. Haripuda. So any questions up to this point? So anything you want to clarify further, so I can do. Otherwise, I'll probably, I hope some of you have received the tune. Uh, then probably I'll give a brief introduction to the subject that will make you probably interested about this subject, and uh, that will help you to like to understand the way I'm teaching also, right? So that's why I'm probably starting a small lesson uh, here. Okay, good. Hope all good, right? So if you have any questions, you can probably type in the chat as well. Um, no issue, right? Okay, Buddha. Uh, okay, this is all about like you can say this motivation speak or probably introduction to this the A levels, whatever, right? So, but make sure that you remember these things for the next 2 years. Right, Buddha. Again, I'll start with a story. Let's go to the 16th century, 15th, 16th centuries. Right. 16th century. Now imagine we are at 16th century. Who were ruling the world? There were kings and kingdoms. The freedom for the people was very less, right? They cannot challenge the authority. They cannot freely come up with ideas. People were suppressed. What was the common belief that time, Buddha? The common belief was Earth is the center of the world, right? Earth is the center of the world, and the entire universe is rotating around the Earth. Can anyone challenge it? It's very difficult to challenge. All believe this is true. But there were people who didn't want to like believe things blindly. Blindly. The reason is they have made new observations. Based on their observation, they understood this is not right. We should challenge this existing idea. We should challenge this existing idea. One of the pioneers in there is Galileo Galilei. What he did is he invented the telescope. Okay, he invented the telescope and he started observing the universe. He saw that there's a planet called Jupiter and there are moons actually rotating around the planet. Ah, what happened? He quickly figured out what we are believing today is not correct. So what was the starting point here, Buddha? New observations, right? Observations. The starting point, observations, right? Observations. New observation leads to new assumptions. Now what he was thinking is, okay, if Jupiter has moon and it is rotating around the larger planet, what about Earth? Earth also should rotate in around the sun, right? And the moon probably rotating around the Earth, and all other planets actually rotating around the sun. So he came up with a new model, right? Observations, new assumptions, right? After several steps, I'll explain it later. He came up with a new theory. So science is now evolving. Science start evolving. Science start evolving. Few centuries after, science was, evolving like this, right? New observation, new theories, new observation, new theories, right? We meet another great scientist, Sir Isaac Newton. What was his observation? What was his observation? He was sitting under a apple tree. An apple was fallen down. If I was there or you were there, what we will do? We'll just eat the apple and we will sleep again. We will sleep again. But he was a very clever person than us. He started thinking why this was happening. Again, observations, new observations. He came up with new theories, right? After new observation, there are a couple of steps to be followed. Putha, I'll explain, but I want to complete the story, right? He came up with new theories, what we all know as Newton's laws of motion. We learn these theories in mechanics. Newton's first law, Newton's second law, Newton's third law, right? And we'll be doing more questions. New observation, new theories, challenge the existing ideas, challenge the existing knowledge, improve the knowledge, right? Improve the knowledge. Then let's move to the 20th century. Science evolved like this for many more centuries. Then we have a person called Albert Einstein. Albert Einstein. What has he done? Newton laws for seems to be perfect, Pudha, right? It all good, like we can apply it to day-to-day life problems, and seems to be answers we are getting also correct, right? But Albert Einstein observed one thing, another new observation, right? Again, new observation. What he observed is the Newton laws cannot explain the motion of objects which are very close to the speed of light, and the object which has extremely large gravity, right? He observed that. So again, he challenged the existing idea. He came up with a new model, new theory, what we call the relativity. He told that he explained this same natural phenomena in a different way. He called it the relativity. See, he told us gravity is nothing other than the curvature or bend of the space-time. It's a bit difficult concept to understand, but mathematically correct, right? Scientifically correct idea. He challenged the Newton's existing knowledge. He came up with a new theory. Science evolved for many years like that. Then we have quantum physics also. Max Planck invented quantum physics, right? He explained us energy is not continuous. It is a combination of tiny packets, right? It opened up a completely new area in science. Again, challenged the existing ideas, came up with new theories, right? This has been evolved for centuries, Pudha. Now we are in the age of AI. This is the area where I did my master's also, right? In the age of AI, all because of what Galileo started few centuries back, right? How science evolved like this, Buddha? New observations, new theories, new observation, new theories. In the middle, we have few other steps also, right? This method we call the scientific method. Science evolves so fast. Civilization probably started probably 3,000 years back, Buddha. But the evolution of science will last probably 200 years, 300 years, compared to last 3,000 years. This rise is, we cannot like compare with the last 3,000 years. Very fast, very fast. The reason is they have a systematic method to evolve the knowledge. This is what we call the scientific method. Scientific method. Okay, Buddha. So this will give us the entry point to the scientific method. Right. Now, if you have the tute, Buddha, you can go to the page number 8. I'm going to explain the scientific method using a small example. Right? Using a small example. All these things are mentioned in the tute, right? So you have an introduction session, what we call from starting from page number 1, introduction to physics and the application of physics, right? There I have mentioned it in very detail, right? How science has evolved for last 2-3 centuries. Okay. Now let's try to understand the scientific method using an example. For that one, I'm going to use a small example, which is in page number 8 of the tute. This is the experiment. Now, this is the observation, right? So this is actually our observation. So I'll tell you what is our observation is. We have 2 ice cubes. Okay, we have 2 ice cubes. One ice cube we have placed in a sunny day, probably outside, right? So let's say that this is probably, we don't know the temperature. We don't have a thermometer, right? This is my ice cube. And I also place an ice cube in probably in a cloudy day where it's not hot as the first day. Now, what is your observation, Pudha? Now I want you to interact with me, right? You can type in the chat what is your observation regarding 1 and 2? Probably you can say me compared to 1, what is the observation of 2, and likewise. I'll give probably 1-2 minutes. Just type your observation. That's fine. It's your first day, right? We'll continue. I hope you have answers in your mind. The observation here is, Buddha, you can definitely observe ice cube in the hot day will melt faster than the ice cube in the cool day. Now this will be your observation, Buddha. When you have an observation like this, what are the questions you are going to ask? Observation, when you have observation, right? The next one is the questions. Why questions? Why this is happening? Why this is happening? The next thing you should come to your mind is why. If you are a good scientist, you should always question things. Why this is happening? Why this is happening? What is the reason behind this? Right? The next thing that should come to your mind is why it is melting faster here than here. Right? So for that one, first I will come up with the assumption. The first thing we can do is come up with the assumption. Assumption based on the observation we had. Right? In the scientific world, we call it the hypothesis. So what is my assumption or hypothesis here? One thing we know about these two environments is temperature here is higher than here, right? Temperature is higher in the hot day than the cool day, right? So this is my assumption now. Does temperature has an impact on the melting rate of ice, right? Does temperature has an impact on melting rate of ice? So this is the first assumption. Does the temperature has an effect on melting time of ice? I'll further improve this assumption, right? I'll say, okay, temperature is high here, no, than here. So I'll tell when temperature increases, melting time decreases. So that is my improved assumption now, hypothesis now. When temperature increases, melting rate decreases. Sorry, melting time decreases. Rate is different concept. I will explain it. Got it, Buddha? So this is our observation. We asked why this is happening. The second step is come up with assumptions. But anyone is going to believe our assumption. So, okay, I came up with the assumption and I went to I will go to one of my friends and say, brother, I saw an observation in a hot day, ice melt faster than a cool day. So my assumption here is, my hypothesis is, when temperature increases, the melting time of the ice is going to decrease. Does anyone going to believe? No. Nobody going to believe stories without any what? Without a proof. In scientific world, we don't believe anything without a proof. That means you have to prove this. To prove that, Buddha, you have to set up an experiment. That is the third part of the scientific method, what we call the experiment. Right, Buddha. So we will write down these two things before designing the experiment. Right. Some people might have the tute, others probably just note it down in the paper, Buddha. Once the tute is received, you can, fill the blanks. Write down the topic, investigating the effect of temperature on melting time of ice. So I'll write it here. Investigating the effect of temperature in melting rate of ice. Right. Then draw these two pictures, right? The sunny day, the cloudy day. Then write down your observation and write down the assumption, right? In the blanks given in the tute. Others you can note it down, right? Then we will discuss how to set up the experiment. I'll give 5 minutes to that. You can write it down. Today I won't take any breaks, Pudha, so we'll continue probably probably 1 more hour, right? But the online classes I normally give a break in between, like if it is 3 hours. I know that when you are looking at a digital screen, it's very difficult to focus for a long time. Probably after 45 minutes, 1 hour, you should have a break. But today, let's continue like this, right? Right. Just write this down, Buddha. So I'll give a few minutes. Hope you can see the whiteboard. There can be small lighting issue. I'll correct it probably from the next week. You can probably send me a signal when it is done, right? Probably raising your hand, probably type in emoji. Or you can just type it is done. Then we will move to the next part, designing the experiment. Okay, great. I'll give 1 more minute for this also. Some students are already done. Very good. So I'll give 1 more minute. Okay, Uta, let's continue. Now let's plan to design the experiment. The reason nobody going to believe our assumptions, so we have to prove it. So I'm going to design an experiment. Right. What is an experiment? Because I think you have just finished your O levels. I hope you already sit for the science subject as well. So what is an experiment? What are the key properties of an experiment? What is an experiment? What are the key features? The first thing we need to remember is experiment is a control setup. What is the meaning of a control setup? What are the control setup? Hmm? Now, what is our input variables here? Input is the temperature. What is our output variable? The melting time. That means, Uta, when you come up with an experiment, all other variables should be identical. So what is my experiment procedure here? Right? So my experiment procedure here is I'm going to test the setup in different temperatures, right? So that's what I have to do. I have to come up with probably 3 or 4 different temperatures, right? So when you change the temperature, all other variables, all other environmental conditions should be same for these 3 setups. Otherwise, you cannot find the correlation, the relationship between the temperature and the melting time. So first property, experiment is a controlled setup. Right? The only variable you are going to change is the temperature. All other variables should be same. Control setup. All other environmental variables other than temperature should be same. Or probably the better word is identical. What is the next property, Pula? Let's assume I am having 3 different temperatures, right? The first one is probably, let's say, inside a freezer, probably 10 Celsius. Second one is probably the air conditioned room, right? 25 Celsius. And probably the third setup is outdoor, which is, let's say, 35 Celsius. My observation is yes, when temperature increases, the melting time has reduced. Now I am very happy, right? My experiment is success and it is aligned with my initial assumption or initial hypothesis. So straightforward, I will go to my friend again and I'll say, brother, I did an experiment. Let me show it to you. When temperature increases, the melting time decreases. Is he going to believe it? Is he going to believe it? Still not to the reason why. The things in the nature can happen only once. We call these kind of things coincidence. Right? In an experiment කරලා success වෙන්න නම් පුතා, the next thing you have to have is the same result should be reproducible. That means if you do the experiment multiple times, the same result should come. So that means the second thing is should produce, should do the experiment multiple times First one is consistency in results. To check the consistency in results. To check the consistency in result. Right? What is the second reason for repeating it multiple times? That's another reason, Buddha. What is the second reason for repeating it multiple times? You know, we all are human, right? We all made mistakes, right? So that means when you read the temperature, you can make mistakes. When you read, probably noting it down, you can make mistakes. When you measure in the time, you can make mistakes. So you again have to run the experiment multiple times to reduce what? Reduce the errors. To reduce to errors. Measurements, we have a separate lesson, Buddha. We will talk about different types of errors. We call it systematic errors, random errors, right? How to minimize those things, all this stuff we'll be learning under measurements. So anyway, we have to repeat the experiment multiple times. First one, to check the consistency in result, to reduce the errors. So we have to repeat it multiple times, Buddha. When we get the same results after repeating multiple times, then only we can claim our experiment is actually, result is actually aligned with the initial hypothesis. Okay, right. Now under the topic experiment, first write down the properties of an experiment. It's a control setup. Second one, you should do it multiple times to check the consistency in the results as well as to reduce the errors. Okay, quickly write down this part also. Now this should be under page number 8 again, under experiment, right? First write down the features of the experiment. I'll give a couple of minutes. You can probably send me a message once finished. Okay, sit done. Oh, I'll give one more minute. Okay, Pita. Hope the time is enough. Right. Now let's go to the setup of the experiment, right? So let's try to set up the experiment now. Right. Okay. So I'll erase this part. Right. Right. Now this is my experimental setup. As I said, we have to check it for three different temperatures. Now this is 10 Celsius, probably a freezer. The next setup is 25 Celsius, which is a room, right? Third setup is let's say 35 Celsius outdoor, right? Three different setups. Now I am going to place three ice cubes. I am going to place three ice cubes. One ice cube here, second one here, third one here. If you remember, I said experiment is a control setup. That means all other conditions should be same. What do you think about the size and the volume of the three ice cubes? Are they same or not? They have to be same to the. Otherwise, we cannot check the influence of temperature. If the size is different, we cannot compare it, right? That's why we call it is a controlled environment. So size and volume of three ice cubes should be same. It's a very important idea, right? Very important idea. What else, Buddha? We need to measure the temperature exactly. Otherwise, we cannot analyze the data we are taking from the experiments. So that means I should have an instrument, measuring instrument to measure the temperature. So we have a thermometer here. Okay, now we are slowly moving to the topics we are going to discuss. We'll have a topic called measuring instrument. So I should have three thermometers here, right? Three thermometers here. What else, Sudha? What else should I have? We need to find the melting time. We need to find the melting time. To measure the melting time, again, I want a measuring instrument. Again, I want a measuring instrument. Here, what I want is a stopwatch. So you should have 3 different stopwatches here. Okay, so we are understanding new idea here, measuring instrument. Measuring instrument. This experiment actually connect to our next lesson. That's why I'm explaining it. Right. Time, I'm going to measure in minutes or probably in seconds. What is this one? Minute means this is the unit we are going to measure. In next lesson, we will understand what is the meaning of unit, what is the real meaning of a unit, right? Here, we'll be measuring temperature using Celsius, right? I'll discuss in detail what is a unit is, right? So although you have learned science for 11 years, probably you haven't have a better idea about what is a unit is. We are going to discuss that. Right. Now this is our experimental setup, right? 3 identical ice cubes, 3 different temperatures. I'll measure the time and we have to wait until the ice cube is completely melt. Measure the time when the ice cube completely melt. Horrible. Now we have set up the experiment and we have carried out the experiment. We measure the times here. I'll say this is T1, T2, T3, let's see. The next important thing, Pudha, when you run an experiment, you have to note down the data. That is the very important step, right? When the experiment is done, you have to note down all the output data. If you remember the first thing I mentioned, right? Doing it one time is not enough. You have to repeat it multiple times. Assume we repeat this experiment multiple times. Okay, now we are going to note down the data. So in the tute, you can go to the page number 9, where we have the data table. All right. Before writing down the data, now let's write down the experimental setup, right? Mention all the important points here, right? Size and the volume of the ice cube should be identical. 3 different temperature setups. We have 2 measuring instruments to measure the input variable and the output variable, right? You have to measure the time when the ice cube is completely melt. Why completely melt? Otherwise, there will be an error in the measurement, right? It has to be completely melt, right? Next one, you have to repeat the experiment multiple times. You have to repeat the experiment multiple times. Okay, Buddha, right. Quickly write down the uh, experiment setup, right? This you should note it down under page 8, right? Again, under experiment. Okay, Buddha, couple of minutes, quickly write down the setup. and let me know once it is done. So do that quickly right now. Okay, Buddha, thanks. Right. Now let's move to the data analysis part, right? Now let's analyze our data. So the assumption is we have repeat the experiment multiple times. Okay. If you want, like if you couldn't write it down, like just let me know. I'll share the recording or the screenshots. So then later you can complete the tube. Okay. Now the people who have the student who have the tube, you can go to the page number 9. So there you have the data table. So it has 3 columns: location, temperature, and melting time. Location, temperature, and melting time. Location, temperature, and melting time. So melting time is going to measure in minutes. Celsius is temperature. Sorry, temperature is going to measure in Celsius. So first location is a freezer or fridge, you can say. Second one is a room, probably air conditioned room. Third one is outdoor. First one temperature is 10 Celsius. Second one 25 Celsius. Third one 35 Celsius. Now let's assume that I have repeat this experiment 3 times, right? And first time I got for 10 Celsius, I got 45 minutes, sorry, 42 minutes, then 45 minutes, then 48 minutes, right? 3 different times, but they are very close to each other, Buddha. So we have a separate section to understand how close these repeated measurements are and not. Based on that, we can say whether the reading is precise or not precise, or whether the reading is accurate or not accurate. So those things we will learn later. But I am going to put the average of these 3 here. Average here is 45 minutes, no? 45. Likewise, I'll place the average values here after repeating it multiple times. Let's say here it is 20 minutes. Here it is 5 minutes. Now this is my data table. Okay, this is my data table. Now let's analyze the data. When you go from top to bottom, what has happened? Temperature increases, right? Temperature increases. What has happened to the melting time? Melting time has been decreased. If you move down, right? If you move down, melting time. Oh, probably I can just mention MT. Melting time has been decreased. We have carried out the experiment multiple times. When we look at the results, now go back to our initial hypothesis. In the initial hypothesis, we said when temperature increases, melting time should decrease. It's aligned with the experiment results. That means our hypothesis is correct. Our hypothesis is correct. That means we can use this one as a theory. We can use this one as a theory. So this can be converted to a theory. මොකද පුතා theory එකක් කියන්නේ? Theory is a generalized, well tested hypothesis, right? Now, everyone should believe this, right? Because we have experimentally shown that when the temperature increases, melting time reduces. So this can be converted to a theory. This is the fourth step of the scientific method. Theory is a well-tested and generalized hypothesis. Nothing else. Now this hypothesis is now well tested, can be generalized. So we call it a theory. We call it a theory. Okay, brother? Right. Complete the table. Mark. When you go down, temperature increases. When you go down, melting time decreases. So you have to write result is consistent with the hypothesis. Hence, we can convert it to a theory. Here is a well-tested and generalized hypothesis. Arvida, complete the table. Mention this one, and under theory, just mention theory is a well-tested and generalized hypothesis. Okay, Buddha. Quickly complete kara. So other important thing, Pudha, when you, start learning in English medium, make sure that you always listen to lectures in English medium, right? You write answers in English medium, because in the final exam, your paper will be in English medium, and it will be a very lengthy paper, right? You have to read it quickly and understand the concepts mentioned there. So don't like cross between two languages. You have selected English medium, please learn in English medium, right? There can be times like, yes, when we want to understand the theory very well, like you can ask probably the single explanation or other language explanation from me, right? Uh, but make sure that you always learn in English medium, right? So you listen to the English lectures, you answers in English language, right? Try to maximize the time you spend um, listening and writing answers in English medium. That will really improve your speed when it comes to the final exam, right? Because it's not our mother tongue, right? So none of have like uh, born to the English speaking like the families, right? So our language can be Sinhala, Tamil, or another language, right? So make sure that you spend next 2 years mostly listening to the English medium lectures and and doing exercises in English medium. Okay, but I hope this is done. So probably I can give 1 more minute. Okay, Buddha. So do you need more time? Or shall we move on? It's okay. This is since this is the first day, but going forward, please try to interact more with that, like either through like reactions, chats, right? So then only like you can improve the learning experience. Okay, Buddha. Thank you. Because we are not seeing each other, right? So it's very difficult to give the one-on-one feedbacks. So I want you to interact so that I understand that you actually understood the lesson we have discussed. Haribada. Now I'm going to probably come up with a better equation kind of explanation to the theory. So let's rewrite the theory like this. Still, this is still not a very like precise theory, but if it is a very precise theory, we should be able to like tell the melting time exactly, right? So if the temperature is 30 to 20 Celsius, what is the melting time in seconds and not? But this is a very basic example, right? So now I'm going to rewrite the theory like this. That means the theory means actually our hypothesis now, right? Temperature increases, that leads melting time decreases. Now this is my theory, right? This is my theory. Now what is the usage of a theory, Buddha? මොකටද අපි මේ theories හදාගන්නේ? What is the purpose of it? Theories help us to predict the fifth steps with the prediction. The theories help us to predict unseen condition. Otherwise, we have to keep running experiments, right? Every time to figure out an answer. So if you have a theory, you can apply it to unseen conditions to come up with the answer, come up with the right value. Now what I am going to predict here is melting time of different temperatures, probably having some ideas about melting time of different temperatures. So I have tested it for 25 Celsius. I have tested it for 10 Celsius. I have tested it for 35 Celsius. Now someone will ask me, based on your theory, let me know what is going to happen at 0 Celsius. What is going to happen at 100 Celsius? As I said, this is a very weak theory. We cannot exactly say that melting time, right? But we can give a rough estimation. So this side, what we observe is here it is 45 minutes, here it is 20 minutes, here it is 5 minutes. So if you move in this direction, at 100 Celsius, it's a boiling water, right? Probably I can say ice will melt in fraction of a second. Ice melt in no time, right? Will melt in no time, right? Okay, you can't see it, right? So I write it here, right? This is what we can predict from the theory we have right now. Again, what will happen in 0 Celsius? Based on this experiment, I can say is going to be a very large value, but we know from the practice that ice is not going to melt at 0 Celsius, right? So probably I can, based on theory, I can say ice, it will take extremely large time to melt ice. Or I can say ice is not going to melt. Both can be said, ne? Ice is not going to melt. Ice is not going to melt. However, now as I said, this is a very weak theory. We cannot exactly predict what is going to happen, but we can forecast up to some extent. Now what I should do here, if I want to make sure the answer, I can run again experiments. I can run again experiments, more experiments, right? I can run more experiments, right? Hope you can see it. Yes, I can run more experiments and I can improve the theory. This is what happened for the last 3-4 centuries, Buddha. We have observations, we come up with hypotheses, we create experiments, we come up with theories, we try to predict the unseen conditions based on the theory we have. If we understood or if we figure out that our current theory is not enough to explain the unseen conditions, we again run experiments, we improve the theory. This is what happened for the last 3-4 centuries, Putha. This is how science has evolved. Because this frameworks allows us to improve the theory or come up with new theories based on the observation. This is a very beautiful model. That's why the modern science, what we call the Western science, has evolved so fast in a very short period of time. Okay. Okay, Buddha. Write down under prediction. Now, this is the our formalized theory. What is the usage of theory? We can predict unseen conditions. Now, these are the two unseen conditions we are going to predict. If it is not, I mean, very detailed or we are not confident about it, we run more experiments, we improve the theory. Okay, Buddha. Write down the last part. Under prediction in the page 9, you can write down this one. And just let me know once finished. So today I wanted to explain how science has evolved and how scientific method has helped to evolve the science so fast. So next week we are going to start the lesson, the physical quantities and measuring units, probably the first starting point of our journey for next 2 years. So time to time, so I'll have some parts of the foundation course also. That means there are some mathematics knowledge that is needed for physics. When there's a situation, there will be a separate tute for that. So when there's a occasion, so I'll explain the theories or the maths knowledge you want for the physics, right? So I'm not going to spend entirely. I mean, I'm going to have separate lecture or entirely spend time on that one. Then it becomes a bit boring for you. So I'll progress in the subject, and time to time, I'll explain that tute also, right? When there's a requirement. Okay, Buddha. Thank you. Thanks for the confirming. Okay, Buddha. So let's finish the lesson for today from here onwards, right? I think you had a better idea about what is my plan is, right? So learning framework also I am yet to discuss, but I'll do it during the lesson, right? How we actually improve you in 4 levels, right? So I'll explain my framework there. But I think you got some idea about my, I mean, learning style, teaching style, and all, right? Um, I know that there are several students who are willing to participate physically but on join online today. So please confirm me within next 2 to 3 days you are going to whether you are going to join online or come to the physical class. So based on that, I'll guide you to the registration process. Um, so hope to see you all in the next week also, Buddha, right? So thank you very much for joining. So I wish you all a good night. So hopefully we'll meet next week. Thank you very much. So please confirm me, Buddha, right, whether you are going to continue. Right. Okay.